Lesson 3, we will learn about set operations. This is the most important lessons of this chapter, and you often use theories in this lesson to show exercise in the next chapters. The first part says about the intersections of two sets. I'm sure you meet the word intersections every day. For example, intersects is where two or more rows meet or cross, or intersections is the common things. So, what intersects in theory of sets we consider? Example, given set A contain natural numbers n, so that n is the divisor of 12, and set B contains natural numbers n, so that n is the divisor of 18. 8. List the elements of sets A and B. B. List the elements of set C containing the divisors of 12 and 18. I'm sure you can handle this exercise by yourselves because it is quite easy, but it's an example, so I'm going to do it. Okay, set A contains natural numbers and a divisor of 12, so A contains 1, 2, 3, okay, 4, and 6, and 12. Crazy. And set B contains, of course, 1, 2, 3, 4, 6, 2, and 9, and 18. And set C contains 1, 2, 3, 4, and 6, cause the common divisor. The common divisors of 12 and 18. And the theories for the sections. Set C containing elements that also belong to set A and to set B at the same time equal the intersections of two sets A and B. You see, set C contains 1, 2, 3, 4, 6, and 5 elements are also the elements of set A and B. Symbolically, we write C is the intersections of set A and B. We use this symbol. Okay, this symbol. And you can see this Venn diagram. This is set A, this is set B, and the common area of set A and set B is their intersections. The common areas is diagonal line. Okay. To help you understand more, about the intersections of sets, I'm going to give an example. I call set D contain -2, -4, 1, 0s, 5, etc. Distinct element, okay, and set E contains random, okay, 1s, 0s, 3, 4, 7s. And if I call F E the intersection sets of D and E, so F will have to contain common elements of D and E, right? So F contains, you see, -2 is an element of set D, but it is not an element of set E. So -2 is not an element of their intersections. Okay. Similarly, -4 plus 1 is element of both set D and set E. So 1 E an element of set F and 0. Okay. This is a way to show the intersections with symbol. The intersections of set A and set B contains is, so that is E an element of set A and is E an element of set B, or another ways, is E an element of the intersections of set A and B if and only if X is an element of set A and X is an element of set B. So this symbol, sometimes we consider it as the word and A and B. A and B, okay? Session II will teach you about another operation of sets, that is, the unions of two sets. Example of these sessions. Suppose A and B are the sets of the students who excel in math and literature, respectively, in class 10E. Given set A contain Minh, Nam, Lan, Hồng, Nguyệt. Set B contain Cường, Lan, Dũng, Hồng, Tuyết, Lê. And there are no namesakes in this class. Let's see B, the set of team of talented students containing the students who excel in math or literature. Determine set C. It's clear that set C contains all students in set A and set B, right? So set C, okay, set C, Nam, etc. Okay, all students in two stack. And the theory for this session. Set C containing the elements that belong to either set A or to set B is called the unions of A and B. This is a Venn diagram. This is set A and set B. The whole area of set A and set B is their union. We write C is the union sets of A and B, we use this C E unions of set A and set B and set B. We use this symbol. Thus, the unions of A and B contain X, such as X is an element of set A, or X is an element of set B. Okay, another way to express X is an element of the unions of set A and set B if and only if X is an element of set A or X is an element of set B. So we can call this symbol the word or, A or B. Okay.